functions like that. Anyway, I was talking about 11 pi over 6 cotangent. Well, the tangent of pi over 6, if you know the ordered pair is root 3 over 2, 1/2, and root 3 over 3. Right there. The cotangent's are reciprocal, so it's 3 over root 3. So if you do root 3, you get 3 root 3 over 3, which is root 3. Question is it positive or negative? You draw a circle, 11 pi over 6, negative is way over here. So that's 11 pi over 6 negative. So all trig functions are positive there, it's root 3. The ordered pair for pi over 3 is root 3 over, no, it's a half root 3 over 2. That's cosine and sine. Tangent's root 3. So this is root 3. The question is it positive or negative? You have to take 3 into 8. 3 goes into 8 twice. That's 6. Subtract, you get 2. So that's 2 pi, and then you got 2 pi over 3 left over. You draw a circle. 2 pi is right here. You're going to go 2 pi over 3. That's pi over 3. That's 2 pi over 3 is right there. All students. That's negative root 3. Cosecant. Reciprocal of sine. We know at pi over 4 we got root 2 over 2, root 2 over 2, and 1. I know the first quadrant. That's what I learned. That's what I was talking about. The cosine is root 2 over 2, and so is the sine. The cosecant's reciprocal is 2 over root 2. If you do root 2, you get 2 root 2 over 2, which is root 2. Now you have to do 3 pi over 4 negative. You go, there's negative pi over 4, there's negative 2 pi over 4, negative 3 pi over 4 is right there. All students take tangents positive, so it's negative root 2. Cosine of pi over 3, we already know it's a half. Question is it positive or negative? So you take 3 goes into 17. 5 times. That's 15, subtract, you get 1. No, 2, sorry. My bad. You get 2. So it's 5 pi, because it's 17 pi, so it's got to be 5 pi, and then you got 2 pi over 3 left over. 2 over 3, so it's 2 pi over 3. As Carol told you, there's an even side of the circle and an odd side. This is the even, this is the odd. You're rotating this way. 5 pi is over here, so we got to go 2 pi over 3. There's pi over 3, 2 pi over 3 is right here. All students take calculus. It's positive. Whenever you see a pi over 2 for tangent, you know it's undefined. Without doing any work, I know it's undefined. I don't even have to do anything there. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, they're all undefined, period. Those are coterminal angles, so that's how you know that stuff. 17 pi over 6. That's the cosine of pi over 6 is root 3 over 2. 1/2. That's the ordered pair. Cosine's reciprocal secant. So it's 2 over root 3. Root 3, root 3. That's 2 root 3 over 3. Question is it positive or negative? You have to divide it out. So you go 6 into 17. Yeah, I think it goes twice. And so you get 12. And you get 5 left over. So that's 2 pi and then 5 pi over 6. You draw a circle. 2 pi is over here. All you need to do is rotate 5 pi over 6. You're right there. Since it's cosine, the reciprocal is secant, it's negative, because it's all students. Pi over 6 again. Tangent's root 3 over 3. That's how fast you can do this stuff. 6 into 35. 6 goes into 35 5 times. That's 30. Subtract, you get 5. That's 5 pi. Then you get 5 pi all over 6 left over. You draw a circle. 5 pi is over here. That's the odd side of the circle, remember? So it's 5, you're over here. I don't care how many times you rotate around. Now you got to go 5 pi over 6. 5 pi over 6 is right over here. All students take calculus. It's negative root 3 over 3. This is a cosecant again. That says 15 pi over 4. We know it's root 2 because we already did it, number 4. Then we're going to say to ourselves, is it positive or negative? 4 goes into 15 3 times. That's 12. Subtract, you get 3. So it's 3 pi, and then 3 pi over 4. You draw a circle. You're over here. You're on the odd side of the circle. You got to go 3 pi over 4. Pi 4, 2 pi 4, 3 pi 4 is right there. Got that? Because we're going in the positive direction. Went 3 times, it's the odd side, then you get 3 pi over 4. All students take calculus. Cosine's positive there. Sine and cosecant are both negative. The last one is a cosine again. It's pi over 3. We know it's a half. Without doing any work, I know it's a half. The question is it positive or negative? 3 goes into 8 twice. That's 6. Subtract, you get 2. It's negative 2 pi, and then 2 pi over 3. This deals with rotation here. You're over here. You want to go negative 2 pi over 3. This is negative pi over 3, negative 2 pi over 3. You're over on this side of the circle. Right here is your triangle. All students take calculus. It's negative a half. And you're done.
Mr. Carroll?
Yeah.
Why would number 9 be negative?
Because we got 3 pi over 4. The cosecant is the reciprocal of the sine. So when I said 3 pi, we're on the odd side of the circle, and then we have 3 left over, so we're going 3 pi over 4. There's pi over 4, 2 pi over 4, 3 pi over 4. Cosine's positive there. The sine, cosecant are both negative.
But why would you start on the odd side of the circle if it's not like a negative?
Why? Well, if you want to go negative 3 pi, sir, this is what you would be doing. Here's negative 2 pi and negative 3 pi. This is whenever you divide it, it's odd, you're over here. If it's even, you're over here. That's just the easy way to do it. Either that or you're just going to have to rotate. So you're going to have to go like this. Once around, there's negative 2 pi right there. And you go negative 3 pi. Well, excuse me, we're going positive here. Sorry, I did that wrong. So we went 3 pi. We were going this way, around this way. So then we got, that's 2 pi. And then we're going to go 3 pi. That's right there. Then pi over 4 is right there. 2 pi over 4 is there. And then 3 pi over 4 is right there. If you want to keep rotating on a circle, you can, or you can learn that this side's even and that side's odd. I'd go to the, what did it say, 3 pi? I'd go to the odd side of the circle and then just rotate the remainder, 3 pi over 4. It's the easiest way to do that stuff. But that's why I went over this with you, because if you just know the first quadrant, you know everything to do. Some of you get caught up in drawing circles. It takes forever. I'm teaching you different thinking strategies in this class. It's all about thinking in here. So I don't know if that makes sense to you, but that's what you're doing.
Mr. Carroll, what was the rule you said for 6?
What was the what?
The rule you said for 6 about being undefined.
Okay. Well, let's look at the circle here. See that right there? It says pi over 2. That's 3 pi over 2, right? Whenever you have something that says pi over 2, for wherever this was, this is number 6. See, if you went 2 goes into 19, 9 times, that's 18. 9 times 2, you subtract, you get 1. So we're on 9 pi right there. So if you went on the circle, if you drew it, you'd be on the odd side of the circle right there, and then you're going pi over 2. There's undefined there, which is 3 pi over 2, and at pi over 2, undefined there. So whenever you see the denominator being pi over 2, or multiple of pi over 2, I know it's already automatically undefined. I don't have to do any work. That's just knowing the values on the circle. Again, every time I teach this class with kids, they want to memorize the circle, and I say you don't have to do that, but if you do it, you're just wasting your time. Any other questions on that? So I wanted to finish up the notes. So I gave you the circle. I gave you all the trig identities. So I'm going back to my note sheet now to show you that we're going to actually use those. I am trying to still record this. There might be 2 versions, so this is what's going on. I'm going to finish the examples, and you're out of here. I hope these don't take too long. So let's find the values of 6 trig functions as shown in the triangle. In order to do this, you have to find the missing side of the triangle right there. We note that this is a hypotenuse right there. This is a leg over here. You have to find the missing leg. Now, many kids want to do the Pythagorean theorem all the time, and I tell them that's a waste of time. If you want to watch, this is the easiest way to do this problem. You take the hypotenuse and square it. So if I take 4 squared, minus the leg squared, minus 2 squared. That's going to be 16 minus 12. No, well, I gave you the answer. 16 minus 4. My bad. 16 minus 4 is 12. So I take 4 squared, which is 16. 2 squared is 4. 16 minus 4 gives you 12. Take the square root. You have to simplify square root of 12. That's 4 times 3. Root 4. Root 3. The missing leg is 2 root 3. Please note you'd get plus or minus there. Side of a triangle is always positive. Got that? Once you have that done, you can quickly do the 6 trig functions. So that's what I'm doing now. I'm going to do cosine, sine, tangent. Across from that I write secant, cosecant, cotangent. The cosine is adjacent. That's 2 root 3 over the hypotenuse 4. Which is root 3 over 2. The sine is 2 over 4, opposite hypotenuse. That is a half. Tangent is opposite, which is 2, over adjacent, which is 2 root 3. That's 1 over root 3. Before I rationalize that, I would just write over here root 3. Then I would go root 3, which is root 3 over 3. The reciprocal of the sine is 2 over 1, or just 2. And the reciprocal of the cosine is 2 over root 3. Again, if you rationalize root 3, it's 2 root 3 over 3. That's how fast you can do those kind of problems if you know how to set up a triangle. Many of you will get caught up in doing the Pythagorean theorem. When you have a hypotenuse, you square it, minus the leg squared, take the square root, and simplify. Any questions on that? Can I turn the page? Can I turn the page?
Yes.
Yes.
Just making sure, because I want to get you behind there. The next problem is problem number 2. Again, there's easy ways to do these problems and there's difficult ways to do them. Most kids choose the difficult ways because they don't think about what they're doing. First thing, I would change this 0.4 into a fraction. 0.4 is 4 over 10, which is 2 over 5. It's important that you know how to change decimals to fractions. If I draw a graph, I know by definition the cosine is x, and the denominator there is the radius. It's x over r. So if I draw a triangle right here, like so, I know x is 2 here, and the radius is 5 there. So just like I did the last problem, I know I have a hypotenuse, that's 5 squared. I'll do it here, 5 squared. That's a leg, minus 2 squared. That's 25 minus 4, which is 21. Then take the square root. The missing side here is root 21. Then you can do the sine of theta. The sine by definition is opposite over hypotenuse. That's root 21 over 5. The tangent, that's opposite adjacent, that's root 21 over 2. Any questions? Can I go to the next one? Anybody? Yes? No?
Yeah.
Okay, the next one's pretty straightforward. It says, let B, or beta, be an acute angle such that the tangent of beta is 4. What's the cotangent of beta? You should be able to tell me that in seconds.
One over 4.
Thank you. Excellent. It's 1/4. They're reciprocal functions. If you didn't know what you're doing, that's the same thing as 4 over 1. Now they want the secant of beta using a trig identity. Well, you can do that. Go back to your trig identities here. Since it's a squared problem, the secant of beta. You'd have to use a Pythagorean identity. It says 1 plus tan squared equals secant squared. So we can write 1 plus tan squared beta equals secant squared beta. We know the tangent right here is 4. So it's 1 plus 4 to the second power equals secant squared beta. That's 1 plus 16 equals secant squared beta. That's 17 equals secant squared beta. Take the square root of each side. You get the secant squared beta, or secant beta I should have said, secant beta equals plus minus root 17. You want the positive value because they want the secant. So the secant is root 17. Now some of you are saying, how do you know it's positive? And I'll show you real momentarily. Note the tangent of beta is 1 over 4. You draw that. We note that's y over x. So x is 1, y is 4. That's that point there. If you draw a triangle, it looks like that. This is 1, this is 4. 1 squared is 1, 4 squared is 16. The hypotenuse is 17 square root. we could do the cosine. The cosine of theta right here, if I write a theta in there so you can see that's a theta. That's a cosine of theta equals adjacent 1 over root 17. The secant is root 17. That's how I know it's positive. So you could do this. They wanted you to use a trig identity. I showed you using a trig identity. And I also showed you how you can label it out, doing a triangle. Isn't this sweet? We're moving right along. If you don't have any questions, can I continue on?
Yes.
These are trig identities. This is where you're going to use that sheet of paper to solve these equations. Right here. These are called trig identities. You're going to use multiples of them. So the first thing I would do is draw a line like so. I take the more complex side and simplify it so it's the easy side. So on this side we don't touch. No touch. You're going to take the more complex side and make it the easy side. The complex side here is sine secant. By definition, we can write the sine is just the sine of x. The secant is a reciprocal of the cosine, so we write 1 over cosine. That's sine x times 1 over cosine x, which is sine x over cosine x, which is tangent of x. You just proved it. You made the one side the other. I'll do the same thing for the next problem. No touch. Now, some of you are going to try to tell me that's the cosecant squared. Well, you can't do that. You have to show why. So you have to write 1 plus cotangent is cosine over sine. But it's squared, so you write cosine squared over sine squared. You need a common denominator. 1 in sine squared is sine squared. Then you say 1 goes into sine squared times. What do you multiply 1 by to get sine squared? Sine squared. So if you take sine squared x times 1, you get sine squared x. Plus, sine squared goes into sine squared 1 times cosine squared is cosine squared. What's sine squared plus cosine squared? If you don't know, you go to your paper, you look at the Pythagorean identity, sine squared plus cosine squared is 1. That's 1 over sine squared. You go to your paper again, the reciprocal identity says 1 over sine is cosecant. 1 over sine squared would be cosecant squared. So this is cosecant squared. It's proved. Any questions? Hello, sweet.
Mr. Carroll,
Yes, dear.
how did you go from sine squared plus cosine squared over sine squared to 1 over sine squared?
Again, you go to your sheet and you look at your Pythagorean identities right here. See right there it says sine squared plus cosine squared is 1. That's where I got it from. So I'm looking at this identity right here. Or you can go
I mean, after that.
huh?
I get that, just the next step, the step after that.
1 over sine squared?
Yeah.
Then I'm going to this identity right here, the reciprocal identity. I know that 1 over sine right here is cosecant. So I said 1 over sine squared. Now, if this is sine squared, 1 over sine squared is cosecant squared. 1 over sine cubed is cosecant cubed. 1 over sine to the fourth is cosecant to the fourth. You have to know the pattern.
Okay, thank you.
Not a problem. Those are how those work. The next two problems are pretty straightforward. Whenever you do a story problem for a right triangle problem, you just draw a triangle. Without doing anything, I'm going to draw a triangle like so. And it says a 12-meter flagpole casts a 12-meter shadow. Find beta, the angle of elevation to the sun. Well, up here is the freaking sun. This is the shadow. There's your flag. So it says a 12-meter flagpole. This is 12 meters. Cast a 12-meter shadow. 12 meters. They want you to find the angle of elevation, beta. There's beta. We have the opposite. We have the adjacent. That's tangent. Tangent of theta equals 12 over 12. Tangent of theta equals 1. Without doing any work, I know that answer because I know my unit circle. Where's the tan 1? What angle? Pi over 4 for 45 degrees. You don't believe me? You take the old calculator, turn on, push clear. This one's in degrees, so we go second, tan, 1. Close parenthesis, enter. See how it goes? 45 degrees right there. How sweet. If you did radians, so you hit the radian button, flip it over to radians, second. Well, I don't even have to do that. What did I do that for? Just hit enter. That's 0.785. Well, if you take pi divided by 4, that's 0.785. And you're done. Wasn't that sweet? And lastly, it says a ramp 17.5 meters in length rises to a loading platform that is 3.5 feet off the ground. Find the angle beta the ramp makes with the ground. So you're just reading this triangle right here. Obviously it's right. So that's opposite, hypotenuse, sine, beta equals 3.5 over 17.5. Take your calculator, I put it in degrees, enter, clear. So now it's in degrees, make sure you're in the right mode. Second, sine. 3.5 divided by 17.5. Close parenthesis, enter. Looks like it's 11.5 degrees. Beta equals 11.5 degrees. There you have it. And that takes care of your first semester for the most part. We'll just be going over 4.3 on Thursday. Plan on a quiz 4.1, 4.2, 4.3 on Wednesday. And we'll finish it up. Your notebooks are due tomorrow. Some people turned in a notebook with nothing there, and I just said, return it back in. Make sure you have pictures of the notes there. Any questions?
No.
Yeah.
Sorry. When you put it into the calculator, why did you put sine -1 or -1?
That's when you're looking for the angle, dear. Here, push clear here again. When you do second sine, that's the inverse of the sine function. So if I just did sine of 3.5, if I do sine 3.5 divided by 17.5, you're going to get the wrong answer. You're going to get a decimal here, which is not the angle. So in order to get the angle, you have to go second sine. That's 3.5 divided by 17.5. Close parenthesis. Enter. That gives you your angle. When you
Okay,
do
thank you.
the inverse. That's what it's called. Inverse. Anybody else with a question? Your assignment's online. You're doing section 4.2. I'm giving you a 14 to whatever, 64 even or something like that. And then you're doing the odds through 65 on section 4.3. They don't take long to do. I know it seems like a lot, but it really isn't. It's just simple questions, and so they should be able to be done. So I'll hopefully that'll work for you. And I'm going to stop recording because this thing is still working. See if it works.